This lesson is on system of equations. So there are two methods that we're going to use to solve for the solution. So we're going to go ahead and review the first method, which is the graphing method. We have graphed the equation in the previous lesson. So what we do is then we're going to use a table and substitute the x values into the equation. But notice in this case we have actually two equations. I have y1 and I also have y2. So I created two tables. We call this x1, y1 right here, which we're going to use to substitute into this equation. And then we're also having this x2, y2, and we're going to substitute into the second equation right there. So let's go ahead and substitute negative 2. So negative 2, if I substitute into this equation, times positive 2 gives me negative 4. Negative 4 plus 3 should give us negative 1. If I substitute negative 1 times 2 is negative 2. Negative 2 plus 3 should give us positive 1. If I substitute 0, 0 times 2 is 0. 0 plus 3 should give us 3. Substitute 1. 1 times 2 is 2. 2 plus 3 is 5. If I substitute 2, 2 times 2 is 4. 4 plus 3 should give us 7. So now if I plot these ordered pairs right here onto this graph right here, we're going to get something like this. Now let's go ahead and take the x2 and substitute into the y2 equation right here. I'm going to substitute this negative 2 into the x part of this equation. So negative 2 plus 2 should give us 0. Negative 1 plus 2 should give us positive 1. 0 plus 2 should give us positive 2. 1 plus 2 should give us 3. 2 plus 2 should give us 4. So if we plot those points, it's going to look something like this. So notice I graphed it on top of the first equation, so we're going to layer that. The reason why we're going to graph it on top of each other is, let's see a closer picture of this. We're looking for is where do the two equations or two lines cross at exactly at the same point. They're going to cross at this point right here at negative 1, positive 1. So wherever they cross at, that is the solution for this problem. Now let's do it algebraically. So algebraically, we're going to take this y1, y2, and we're going to set them equal to each other. So what I just did was I took this x plus 2 right here, and also this 2x plus 3, and I just set them equal to each other because this is y and this is y as well. Okay, so once we set them equal to each other like this, we're going to go ahead and solve it algebraically. So I'm going to go ahead and bring the x over to the other side where this x is right here, and we're going to bring the number over to the other side to where the number is right there. So it's going to look something like this. 2x minus x is equal to 2 minus 3. We're going to combine like terms. So 2x minus x gives us 1x. 2 minus 3 gives us negative 1. Now normally we would stop right here, but what we're looking for is an x value and also a y value. So I'm going to take this x value of negative 1 and I'm going to substitute it into one of these equations to figure out what the y value is. It doesn't matter if I substitute into the y1 equation or y2 equation, it's supposed to get you the same answer. So I'm going to go ahead and substitute into the first equation of y equals 2x plus 3. So again, that x equals negative 1 is going to be substituted into that equation right here. So it looks something like this. We're going to get y equals 2 times negative 1 plus 3, which is equal to y equals negative 2 plus 3. And then we're going to get y equals 1. So then from this part right here, algebraically, we're going to put it into ordered pairs. And when we put it into ordered pairs, it's going to be x equals negative 1 and y equals positive 1. So now let's go back to that graphing and let's talk about that. So if we put that side by side, what happens is graphically we get x is equal to negative 1, y equals positive 1 is where they cross at right here. And algebraically, it also comes out to exactly the same answer. So that's going to be the two methods that we're going to use to solve for a system of equations. So let's try one more example. I have y1 is equal to 2x plus 1, and y2 is equal to negative x plus 4. So again, we're going to substitute in the negative 2 into the first equation. So negative 2 times 2 is negative 4. Negative 4 plus 1 should give us negative 3. So negative 1 times 2 is negative 2. Negative 2 plus 1 should give us negative 1. 0 times 2 is 0. 0 plus 1 should give us positive 1. 1 times 2 is 2. 2 plus 1 should give us 3. 2 times 2 is 4. 4 plus 1 should give us 5. So again, we're going to go ahead and plot that out, and it's going to look something like this. Okay, now let's do the second equation. So for x2, my value of x is going to be negative 2, and we're going to substitute into this equation right here of x2 equals negative, be careful of this right here, negative x plus 4. So if I substitute in negative 2 into this x right here, it's going to be a negative times a negative 2 plus 4. All right, so negative times negative should give us positive, so that's positive 2 plus 4 should give us 6. So negative 1 times negative 1 should give us positive 1. Positive 1 plus 4 should give us 5. 0 times anything is 0. 0 plus 4 should give us 4. Positive 1 times negative 1 should give us negative 1. Plus 4 should give us 3. 2 times negative 1 should give us negative 2. Negative 2 plus 4 should give us 2. So again, now let's go ahead and plot that point, and it's going to go this direction. Notice that this is going this direction. It's going a negative slope, and this is a positive slope right here. All right, so let's focus into that and figure out where do they cross at. So do you see the point that they are crossing at? It's crossing right here at that point of 1, 3. Okay, so that's graphically, we found out it crosses at 1, 3. Now let's do algebraically. So again, algebraically, we're going to set the two equations equal to each other, and then we're going to solve for x. So we're going to bring the x, negative x over to the other side, giving us positive x. We're going to bring the 1 over to the other side, giving us minus 1. So then 2x plus x is equal to 3x. 4 minus 1 should give me 3. If I divide both sides by positive 3, x is equal to positive 1. So again, I'm going to substitute in this x equals 1 into either y1 or y2 equation. This time I'm going to go ahead and put into y2 equation. So y equals negative positive 1 plus 4 should give us 3. So again, the coordinates is 1, 3. So now side by side, graphically and algebraically, they come out to the same answer. So that's also when you know that you have done it right, if when the answers are the same. If one of those answers does not match, then you either did it wrong graphically or you did it wrong algebraically. So that's a way to check yourself.